So today we are going to continue the topic of friction. And yesterday in the previous class, we developed this concept that friction is a force that opposes the movement of the body, right? And it always acts in the direction opposite to the motion, to the movement. It can slow down the object, and even it can stop the moving object. So we are going to talk about the types of friction here. Types of friction. So the first type that we need to discuss here is static friction. Static friction. Static friction is, it prevents an object from slipping, right? It prevents object an object from slipping, right? So this occurs, the static friction, this occurs between two solid surfaces, right? Two solid surfaces that are at rest and not moving, relative to each other, okay? Relative to each other. That means if we are applying force and the two objects um, are sticking together and they are not moving relative to each other. So the applied force that we have applied is balanced by the static friction. Okay, so static friction is is the friction that stops the object to move, and it prevents the object from slipping. Okay, so static friction is usually is usually greater or greatest force you need to overcome to get an object moving. Okay, so this force, this friction is usually the greatest force. Okay, uh we need we need to overcome we need to overcome to get an object moving. Okay, to get an object moving. Now, any question till here? Yeah, any
No.
question? No. Okay, so let me show you that how static friction works, in which case it can work. So let me draw um kind of mm, a box here. Mm, Let me try to make that box perfectly. Oh, sorry. Let's say there are two boxes, right? And one box is for another, right? And what is happening here? Here is the static friction, okay? The friction that that has stopped the object to move, okay? So if the static friction is to the left side, so the another friction is going to be to the left side, right side, okay? So this is how these two forces are getting balanced, right? So this object, the object that is placed here, this one, over this one, the the both are stick together, right? They both are stick together, right? So this is the part, this is the portion that separates these two. Okay, so this is how these two objects stick together and they are unable to move because of the static friction. So larger force, greater force is needed to overcome this friction. Okay, so now the second friction is the kinetic friction.
Sorry, I have one question.
Yeah.
Like real life example, like what type, when would we use static friction?
Okay, for example, I have placed a laptop on the table, right? Now, if I want to drag my laptop, right, and I'm trying to push the laptop without holding it, without lifting it. So if my surface is too, stiffy or kind of roughness is a lot of roughness is there on the table, right? So maybe a mat is placed uh, below the laptop, so the laptop is unable to move, so they stick together, so large force is needed to move that laptop or object, right? So this is how lot of roughness, due to a lot of roughness is there, or somehow a vacuum is created. If the vacuum is created, yes, static friction will also be greater over there. Okay, right? I hope I have cleared your concept.
Yes, yes, yes.
Okay. So kinetic friction is also known as sliding friction, right? Kinetic friction is also known as sliding friction, okay? And in some books, it is known as dynamic friction, right? And see, this type of friction is normally, is present when you are trying to move the object and the object starts moving, right? It just starts moving. Okay, so let me show the one picture so that you will be able to uh, draw the concept easily. Um, Kinetic friction. See, this picture will clear your concept of kinetic friction. See, you are pushing, you are trying to move the object, right? And the object is, is has started moving. Okay, the object has started moving. So the moment that it starts moving, so it's going to have the friction. Okay, we can't say that when the body comes under the motion, it doesn't have the friction. It has the friction because it is in contact with the ground. Okay, right? So you are pushing the object to the left side in this, according to this diagram, right? According to this figure, you can see here, you are pushing this object to the left side, and against the motion, here's the force of friction that is that exists here due to the contact with the ground. So this is called a kinetic friction. Okay, so kinetic friction exists when the object starts moving. Clear? Okay, so uh this occurs between two solid surfaces, right? That are sliding past each other. right? The second point, you can say that to reduce both static and kinetic friction, lubricant, right? Lubricants like oil, okay? Oil between surfaces are used, okay? Right? So I hope there is no confusion of between the kinetic and static, right? The third friction is the fluid friction, right?
Wait, can you hold on? Right
Okay.
in this.
What what do we understand by fluids
Fluids like liquid.
and liquids
I don't.
and gases? Okay.
Yeah.
Gases in physics, we consider fluid as gases and liquids. Okay. So when the object is submerging and is moving in the liquid, right? So force of friction exists on it, right? Okay, so let me show you uh one picture here, so you'll be able to understand the concept of fluid friction. See this one. Yeah, so the object is flying. So the plane is flying, so that means the air resistance there, right? And the force, that is from the engine is going to be the thrust, okay? The forward force or the force from the engine is to the left side. I'm referring to the plane, right? I'm referring to the plane, okay? So here, the thrust is the forward force. Thrust is considered as a forward force, right? Or we can say the force from the engine, that is thrust, okay? And yes, air particles are there. Air particles are there, right? Yes, air particles, the fluid air
Yeah.
is there. So they are, pushing this plane. Okay. So this is how the air is acting in opposite direction of the motion. So air resistance is towards the right side and thrust is towards the left side, right? Okay. So this will be considered under fluid friction. Air resistance is the type of the fluid friction. Air resistance is a type of the air resistance. Air resistance is the type of fluid friction. Okay, because due to the air particles, and air is a gas, and gas is considered as a fluid. Okay, fluid friction. Right? After that, you can see this another picture here. The boat is is there, and water resistance also there. Weight is acting downward, and the upward force is up thrust, right? So if the boat is moving to the left side, so against the motion, there's a water resistance. Okay, so water resistance, yes, you can directly say this is due to the water, and water is the fluid, right? Okay, so water resistance is also type of the fluid friction. Okay, right? So what we can say that this friction, fluid friction, okay, fluid friction is this is the this is the resistance an object experiences, right? Experiences when when moving through fluids, okay? When moving through fluid, and fluid means liquid or gas. Clear? So what do you think if we speed up the object? So do you think that the fluid friction will become greater? The drag
Yeah.
also increases?
Yeah.
Yeah. So if speed, if speed increases, so fluid friction, fluid friction, or we can say drag also increases. Okay, clear? And the point comes, and this is not the part of this topic, but I want to include it here. The point comes, comes, the time comes where object starts moving with constant speed. Okay, right? Constant speed. Initially, what you try to speed up that object, right? And the drag or the friction increases, right? But the point comes where the both, forces become balanced and the object starts moving with a constant speed. This constant speed is also known as terminal velocity. What do we call it? Terminal
Good.
velocity. Okay. Because this velocity is constant after the body has reached to a constant speed after facing the friction. Okay, when the speed is increased, initially the speed is increased, right? And the friction also increases, right? So eventually, finally, the terminal velocity is reached. The object reaches to the terminal velocity and it is moving with a constant speed, right? So surface, how can we increase, if I increase the area of the object and decrease the area of the object, so what will happen? For example, if I say that the car is designed from the front side, it is designed sharp. So what is the purpose to have the car to have the sharp edge from the front side? Yes. What is the purpose to have the
But
sharp edge?
when the object has a sharp edge, for example, a car,
Yeah.
object is more streamlined, which
Mhm.
is good for it decreases air resistance. Or
Excellent. Exactly. So the less surface area will will overcome the fluid friction. Clear? Overcome the fluid friction. Clear? I hope that this concept is clear to you, right? If I increase the surface area, what will happen? If I make a car like this, right, from this front side, right? So what will happen?
more drag, more friction.
Yes. So the greater surface area, greater surface area will have greater drag, right? Yes.
Yes.
Okay. So finally, we have completed the three types of friction, right? Static friction, kinetic friction, and the fluid friction. Okay. Now we are going to talk about the stopping distance. Um, if I start the stopping distance, I won't be able to cover it in today's class. So I don't want to break it, this topic, because I would like to discuss this topic in one class, stopping distance, because we need to connect with the velocity time graph. Okay. So there are the factors that affect the reaction, there are the factors that affect the stopping distance. Okay. So I would like to discuss this topic in the next class, right? Because it won't be completed in this class because we have only a few minutes left. So I would like to put a stop here. So the whole friction topic is completed, right? Okay. So should I share the syllabus so that how much we have completed?
Yes.
Okay. Okay.